PPTC 121. Power Plant Steam Systems. Session 6. Session Objective. The objective of this session is to define the factors that must be understood to properly construct and maintain boilers, such as the American Society of Mechanical Engineers Code, stress, types of metal failure in boilers resulting in cracking of the metal, and means to test for that cracking. Agenda. Define what the American Society of Mechanical Engineers Boiler Pressure Vessel Code. Understand tension and compression. Understand material stress. Understand elongation, elastic limit, and ultimate strength. Understand graphitization. Understand and calculate the stresses on a steam drum. Define minimum wall thickness and calculate it. Define the efficiency of a joint or tube ligament. Understand drum construction. Understand why X-ray procedures are used to ensure the integrity of a weld. Define welding. Define the throat of a weld, a fillet weld, a double welded butt joint, and a single welded butt joint. Understand the meaning of destructive testing and non-destructive testing. Define ultrasonic testing technology. Define what the American Society of Mechanical Engineers Boiler Pressure Vessel Code is used for. Defining the safety requirements for steam boilers, the design and fabrication of steam boilers, and the proper inspection of steam boilers. The purpose of the code is to assure that life, equipment, and property are safely protected during normal and abnormal service, and to define the construction features of pressure vessels. An understanding of tension and compression is important in understanding how boilers can fail. When two forces are acting on the ends of a bar or plate and are acting in opposite direction, the bar or plate is in tension. When the forces are acting toward the center, the material is said to be in compression. Just what is material stress? Material stress is the internal resistance that the material offers to being deformed by an external force. Material stress is defined as the internal force divided by the area over which the stress is applied. The main importance of stress in its magnitude and the nature of the load and resulting stress distribution is also important. When examining material, you need to understand elongation, elastic limit, ultimate strength, and ductility. The definitions are: 1. In the case of tensile stress, the deformation is called elongation. 2. The load in pounds per square inch required to cause the material to be permanently deflected is called the elastic limit. 3. The load in pounds per square inch required to cause complete failure in a piece of material is called the ultimate strength. 4. Ductility of a metal is determined by measuring the increase in length, or total elongation, and the final area at the plane of rupture after the specimen is broken. Looking at the drawing, you can see items such as elongation, elastic limit, ultimate strength, and the failure of the material. Here is an example of a stress calculation. The force applied to a rod is 4,000 pounds. If the rod is 1 inch in diameter, the area of the rod is equal to pi times the diameter, or 3.14159 times 1 divided by 4, which equals 0.7854 inches squared. Therefore the stress is the force applied divided by the area of the rod, or 4,000 divided by 0.7854, which equals a stress of 5,093 pounds per square inch. What is material creep? Material creep is the combination of stress and high temperatures which results in changes to the internal structure of steel. When the change is small but results in a permanent deformation of the steel, the change is known as material creep. Just what is graphitization? Graphitization is a change that decreases the strength of steel. That occurs as the result of an internal structure change in the steel due to the separation of graphite within the steel. Here are some pictures of graphitization. The steam drum is the place where the steam separates from the boiler water. It is a large vessel that is under a huge amount of stress. So how do you calculate the stresses on a steam drum? There is both hoop stress and longitudinal stress, and each needs to be calculated. Hoop stress is the stress exerted on the sides, and the longitudinal stress is the stress exerted on the ends on the drum. What you really need to know is the allowable minimum wall thickness to handle the stress exerted on the drum when under operating pressure. See the example on page 143. What is the minimum wall thickness, and how do you calculate it? Minimum wall thickness is defined by the minimum required wall thickness is equal to the internal design pressure times the inside radius of the drum divided by the product of the allowable stress of the material at the design temperature and the efficiency of the weld joints, minus 0.6 times the internal design pressure. Or T is equal to P times R divided by S times Z minus 0.6 times P, where T is the minimum required wall thickness, P is the internal design pressure, R is the inside radius of the drum, S is the allowable stress of the material at design temperature, and D is the efficiency of the weld joints. For example, radiograph or X-ray of the joint equals 1.0. Here is an example of a calculation of minimum wall thickness. A drum will be constructed of SA 285 grade B carbon steel by welding. The internal design pressure is 800 pounds per square inch, and there are no reinforced opening in the drum. The weld joints will be radiographed. The drum's inside diameter is 60 inches. What is the minimum wall thickness of the drum? T equals P times R divided by S times Z minus 0.6 times P. T equals 800 times 30 divided by 12,500 times 1 minus 0.6 times 800, or T equals 1.99 inches. Boiler steam drum construction. Steam drums in today's boilers are fabricated from thick steel plates and forgings and are joined together by welding. The development of the steam boiler has been concurrent with advances in metallurgy and continuing improvements in fabrication methods, including welding of steel and alloy plates. Define the efficiency of a joint or tube ligament. The efficiency of a joint or tube ligament is found by dividing the strength of the section in question by the strength of the solid plate. When the calculations or destructive test show that the joint or tube ligament fails when subject to 1/2 as much force as the solid plate, the efficiency is 50%. The efficiency of the ligament is equal to P minus D divided by P, where P is equal to the pitch of the tube hole, and D is equal to the diameter of tube hole. Steam drum pictures. Please notice that the steam drum has numerous connections to it where water flows in from heated boiler wall tubes, and out of the drum to the unheated downcomers to feed water to the heated boiler wall tubes. There are also the steam outlet and feed water inlet connections. Modern boilers and their steam drums are constructed using sophisticated welding techniques. So just what is welding? Welding is the joining together of one or more materials by the application of heat that is localized in the region of the joint with or without the addition of a filler metal. Welded joints relieved the operator the inconvenience caused by joint leakage and the necessity of calking. Welding lessens also the possibility of caustic embrittlement. Welding allows for higher and higher design pressures. What are the different types of weld joints? 1. A fillet weld is approximately triangular in cross-section with the throat in a plane that is 45 degrees to the surface joint. 2. A double welded butt joint is one formed by adding weld metal from both sides of the joint and reinforcement on both sides. And 3. A single welded butt joint is one formed by adding the filler metal and reinforcement on only one side. The throat of a weld is the joint where the filler material is at a minimum thickness. Welds can fail, so how do we assure ourselves that the joint will not fail when subjected to normal operating stress? A weld and/or the material are thus tested to assure that they will not fail. There are several types of testing that are used. The destructive test is one, in which the metal is stressed until it fails. The nondestructive test, NDE, is one in which the metal isn't injured, and therefore may be applied to a completed vessel. Some popular types of NDE testing are X-ray and ultrasonic testing. What are the X-ray procedures that are used to ensure the integrity of a weld? Radiographic testing, RT, is a non-destructive testing, NDT, method of inspecting materials for hidden flaws by using the ability of short-wavelength electromagnetic radiation, high-energy photons, to penetrate various materials and leave an exposure on film. This film is then examined for flaws. Fusion welding was developed as well as X-ray procedures to ensure the integrity of the weld. What is ultrasonic testing (UT) technology? Ultrasonic testing (UT) is the technology that has developed rapidly in the NDT of pressure parts. The ultrasonic wave that is produced is reflected by any flaw in the material being examined. The wave is then displayed on an oscilloscope. The common cause of pressure part failure is the loss of material that results from oxidation, corrosion, or erosion. Here are some pictures of ultrasonic testing (UT). Note the device being used for the examination on the left, and the marking of the results in the picture on the right. What this type of testing can prevent are failures like this. This is called a fish mouth failure, or this fish mouth failure. The energy released in a failure such as this can be tremendous, and can quickly erode surround tubes resulting in more failures.